speaker today, David Odari, is a very senior Android developer. He has been in this field for a very long time, and if you really follow his work, you can see how enough consistency you can grow very quickly. So, guys, in our presence, we're going to have let's welcome David Odari. We had a session with him a while back, and it's an honor to have you back again. We should keep on with this community of our small community of ours as it grows. So, yeah, David Odari, you're very much welcome to Mount Kenya University GDSC. There are so many aspiring young developers here who really wish to follow your footsteps, and hopefully one day at a time like this, they'll be presenting to other junior developers. So guys, it's an honor to have David Odari here, and I'm pretty sure this session will have so much impact in your Android development journey. So David Odari, you're much welcome again, and it's nice and always fun to have you here. Thank you. Welcome, David.
Thank you. Yeah, so I'm David. I think that's a lot of introduction done. Yeah, I was used to live in Kenya, moved to Germany, been working here for around 3 years. Overall, I've been doing Android for almost 6-7 years. And yeah, I think today we are here because of dependency injection, and I'll just go ahead and share my screen because I had a few. I think it's going to be a bit practical. Share my entire screen. Also, let me know if it's visible or not.
Yes, it's visible.
Cool.
Yeah.
Yeah, then I can go ahead and do what I intended to. So dependency injection. And I think this is something you will definitely encounter so many times, especially when working in a professional environment, big apps, medium apps, and you will not avoid this concept. I think someone raised their hand. Wants to say something. Okay, I'll go on. So what is it really? So probably when you look it up, you'll see this might be the 3 top key phrases or keywords: like design pattern, inversion of control, separation of concerns, and that can feel a bit confusing if you're just starting or you're not particularly familiar with the software engineering terms. So how I will describe it is it's a design pattern. Design patterns are just patterns we commonly use in software engineering from time to time. Like if a problem occurs frequently, a solution is brought forward and it's considered like a design pattern. Like it's a pattern most people will use. So it's a design pattern used to decouple an object or a function from its dependencies and have them receive them from elsewhere. So rather than have a something tightly coupled, what tightly coupled means is the thing or the dependencies, the thing that this thing is depending on is very let's say, yeah, I think I don't think there's any other way to say tightly coupled. It's just tightly coupled. And I think the best way to show this is with an example, or rather describe this with an example. So let's imagine you have this car manufacturing company, right? And one of the processes here is, depending on the type of manufacturer, we need to paint it differently, right? And we can't really hard code, the paints for each individual car in the system that is not really efficient, we have to rely on something to tell us this is the car that we have now, give it this color. So if we were to hard code like colors for each and every single car that comes, that's what I mean by like it's tightly coupled. It has all the information it needs in one central place. And dependency injection brings about this idea of loose coupling, where you don't really have to know or care about where this thing is coming from. Someone or something somewhere will provide it to you. So that's what I meant by decoupling the objects and functions from the dependencies it has. And I think then the next point from here will be to show it in real life. I think that's the best time to code. Enough talk. I think I've talked too much. And I already had like a small project. Wait, how do I exit this thing again? I'm sorry. Escape. Yes, escape. Yes, so I had this. Can you see Android Studio? Just checking. Okay, confirm.
Just zoom in a little bit.
Okay. So I will zoom in. Increase. Let's do this. Point. Or let's maybe change the view. Yeah. I do that when I'm in settings. Cool. But this won't show everything I want to show. So for let me first enter exit presentation mode just to show. So I already have like a basic project, and what it has is a couple of classes. You have your car, your response, a local storage, a repo, a service with the API, and a view model. Pretty much what you'll probably come across in most. This is like a very, very simplified version of what you'd come across in most apps. And there's somehow all these classes, objects, functions have to work together to provide data to a screen. And how do we connect all these things to display data? So I think the first thing you probably might need to do is okay, I wanted to go to presentation mode, but the issue I have with presentation mode is I don't have access to the file. Usually don't have access to the file folder. Just make the font hella big. Nothing is changing, which is strange. Does JetBrains not have that size? Yeah, I think I'll just let me try and see. Okay. Okay. So the first thing, or rather, you probably have like things like interfaces, and with dependency injection, or rather, let's just start. We're just starting from scratch. This is a new project, no dependency injection yet. Just to show you how we build up to dependency injection and why dependency injection is useful and how tools like Hilt help. So I will create quick implementations of the interfaces I have. So probably let's see something like storage that's implemented. And I need to do one for the repo and the service. So cars repository info class, then it needs to again do the interface. Cool. And then again I have to do this. So you can see, you can imagine if this was a large project, how this will also be a bit boring to do. But like a SCAS service, I can just leave it like that. So we have this and this implementation. So let's say the repository depends on, like the local storage. We have like a local storage, no, not just local storage. Always using interfaces. Then it also depends on what else is the service, because service. So let's say if you didn't have interfaces, we'll probably say we don't really need interfaces. We can just, do this, just put the implementations directly. And yes, that will work. But the thing is, in most real life projects, there might be different implementations of this. So that's why we use the interface, and we can switch the implementation how we want, and that's one of the advantage of dependency injection. So it's just too big. This should be fun. And that is what we have. So this is a very simple showcase of dependency injection. By using things like interfaces instead of actual implementation, you can swap out the classes to whatever you want. Also using, this is called constructor injection. So by constructor injection, what do I mean? So if I was to remove this, and instead I came here and did this val local storage implementation, local, what's the name again? Cars local storage implementation, and car service. And let's say we have car service implementation. This doesn't exist. So as you can see, this would have, this works, right? It would, we could be able to access whatever we want. We can get our cars from the local storage and get cars. We can do car service. We can fetch cars and do whatever it is we want and return our list of cars. So the thing is, every time you use this repo, it has these objects created inside of them. And going back to how we described dependency injection, we said we are aiming to decouple or decouple the objects or functions from dependencies that it needs. And what we are doing here is tightly coupling it so that it's already merged to like implementation details. And this is what tight coupling looks like. If we wanted to use a different service for our cars, we will have again to come all the way to the code and detangle this mess and modify the code and everything in etc. this also will beat the purpose of us having like an interface. Like I described before, the benefits of using an interface is you can swap out things as you want. So because it was to come again to the view model, and maybe I need the repository. So this is how, yeah, I guess this is how it will look like. So the car repo impl, and then you can just get the cars for the UI. So all this, if I was to test this, it will be also hard for me to test because I have to go all the way to where it was implemented to change it or modify it or fix it. Also, if you write unit tests, or if we do start writing unit tests, usually the object that you have, or the class, the function, if it is not receiving any parameters, its parameters are like created inside, it becomes very hard to test or swap out the thing that you're trying to test. So all your tests will be dependent on the actual implementation. For example, if I'm writing a test for this repo, right? And this is the real implementation. And the real implementation calls a database or fetches data from an API server somewhere, and this takes time. Now imagine you're working on a big app. It has 400, 500 tests that rely on this. So you can imagine all those calls get hit every time you're running your tests. So to avoid this, you can now make use of constructor injection. And that is usually the first concept you'll run into when talking about injection. And this is why it's called injection, because you're just injecting things into in between the parentheses. Where is the, what's the name of the car service? The car service and local storage. Yep. Now we don't care where this comes from. Someone else will take care of creating this for us somewhere else. And yeah, we have no idea about the implementation. This is moved to somewhere else. Yeah. And yeah, that's pretty much it about constructor injection. Then you have the storage. The storage maybe has, if you're using a library like Room, SQLite, etc., probably have another constructor providing it with something else. And if you have, let me just create it so that we have much a visual view of what I'm talking about before I go into it. Let's say you have a Room DAO interface. So a Room is like a library, like a ORM, like a database library used in most Android apps or whatever it is that you're using. There are other libraries you can use, but Room is quite common. So let's say the local one also has like this Room DAO. And you can imagine all this ends up being used at the repository, right? So you have this car repository info. This is the implementation of the repository. Then you have to come and implement the car service info. Car service, where is it? I don't think I created this one. Info. Then you have to come and do cars. I want you to see what's about to happen here. Then I have, maybe I need Room DAO info. So you can imagine if you have a repository that has a lot of constructors, you have to build this very long object, this very huge object, and you have to keep writing impl and remembering all the objects and not missing anything. And this can get quite overwhelming quite fast. So again, I'll remove this here and call this repository from here. So that way I don't care about creating all these objects from the whole chain from the bottom to the top. And that's like one of the reasons why manual. So what I was doing is kind of manual dependency injection, and some of you might have seen it can feel very confusing or overwhelming. And this is where libraries like Hilt come in and make your life a bit easier. There's Hilt, there's Dagger, there's other libraries like Coin and etc. But Hilt is a lot of older apps are using Dagger, and I think for them to adopt maybe new or easier ways of using or rather making the dependency injection easy, because Dagger could also get out of hand the bigger the app gets. Hilt was brought forth, and it kind of removes a lot of the noise, I'd say, that you'd see with Dagger, a lot of the complications, or being like a super expert at debugging and figuring out what's the issue with your DI framework. So I think from here we can start making use of Hilt and see how that comes into play. So to do that first, we need to add the dependencies. So I don't think I have Hilt here. No, I'll need to go fetch those from somewhere. So I need to get this. Is this a Groovy? Yep. So I need to add. You need to add. There's this Hilt Android Gradle plugin that you need to add to your root. So by root, what I mean is this. I'll just paste it here. Then you also need the Kotlin capped and Dagger Hilt here. Go and add it to your module. If you have multiple modules, yes, you just have to put it over here. Next thing is you add your dependencies here. And go to the dependencies, paste it here. The Android documentation has come a long way, and it's way better now than it was. And I think allow references to generated code. Yeah, this is not really a must unless you are. Yeah, if you need like to call something from the generated code. So what I was writing before, creating all this impl, building all these constructors. So what Hilt will do, it will create all these implementations for you behind the scenes. You don't have to care about any of that. All you have to do is make use of the constructor injection technique, and everything should be fine. And this should be fine for now. Sync the project and check. Checking. See, yeah, I think that's pretty much it. Did I miss something? Java versions 8. Is there anything else? Okay, cool. Everything should be fine if you just inject. Now, once you add Hilt, the next thing that you probably will have to start doing is set up the annotations. And the Hilt annotations, there are various Hilt annotations that serve various purposes. And the first and most important one is the Hilt Android app annotation. So this is used for most of the configuration and the objects that will need to survive the entire the app lifecycle. So the Hilt annotations are also kind of tied to the lifecycle of the component you're tying them to. If it's the app, it's going to be more global or more tied to the app's lifecycle. If it's like an activity, it's more activity scoped, and you can create custom ones for things, for other like things which have a smaller scope. But we won't be doing that today. I'll just keep it very, very high level. So the first thing I'll do is create something. Where's the? I think I'll just call this cars app, and cars app application class. And no, this is not what we'll be doing. The autocomplete, I think, is being done by Git Copilot, in case anyone is wondering. So cars app application, and what you need to do is come here and say Hilt Android app, and that's it. Also, because we've decided to extend the application class, we need to tell register it in our manifest that this is where the app is coming from. The application creation is coming from this. Yes, so Hilt. So this is a Hilt Android app. The other important place where we need to go check is probably your entry activity, the main activity or the entry activity. And I'll call this Hilt entry point. No, it's not Hilt entry point, it's Android entry point. Yes. So the Android entry point is this one is usually used to mark Android components. Yeah, so this is one of the other key ones that we'll see a lot. There's a list of these different components, and let me see, there should be like a table somewhere down here. No, this is not the one I'm looking for. There should be like a table, or if there's none, I guess that is something to look into. So yeah, but there should be some kind of table somewhere telling which says which entry point, the entry points and the entry points and the common annotations, like the Hilt Android app. The next thing I'd probably want to do is, so we've already initialized Hilt, defined our entry point, defined the app, configuration, and where the kind of the starting point for the app is, but it doesn't know how to provide all these dependencies. So for it to be able to also create these things for us, we need to come here, for example, to the impl and say you have to mark your constructors with something called inject. So the inject is, it's pretty much a standard used in most dependency injection. It's not exclusive to Hilt only, it's just like a standard. So you just have to come and say inject, and the constructor, and the constructors of your implementations. I'll just come here and say inject. Constructor. What else did I have? Input. No. You just inject where, even if you're planning on providing this, even if it didn't have like anything, it still would have to do this. Cause repo view model. So yeah, for the view model, there's going to be an extra notation. So inject constructor. Okay, let's import this. And for the view model, it's going to be has something extra. And why is this the case? So first, I'm going to put Hilt view model. So when you're injecting or using the AndroidX, this view model class, the idea of this class is it's responsible for holding and managing UI-related data in a way that's lifecycle aware, and it's supposed to survive configuration changes. Configuration change could be when someone, I don't know, changes the settings, dark theme, light theme, tilts the phone, like the app, like a lot of, basically, if there's any change in configurations. And the values are kind of supposed to survive this configuration change. The view model was built exclusively for things like this, and this might not be the case for other kind of classes. So yeah, this kind of builds the behind the scenes. The view model will be built in a way that supports this functionality, or making it supports this functionality, keeps it in mind. So when you're using a view model with Hilt, remember to include this. But also, I think if you forget to put the right annotations, there will be crashes, or there will be a compile time errors that will be shown, that will give you a hint of what you're supposed to fix. And with that done, I think, is there any other thing that? Yes, so the other thing that you might then want to do with Hilt is there are things called modules. And let me say that module, for example, and this is going to be an object. Cool. And so this one, usually it's like the place where you define the things you want to provide. I think from this comment code, you can see it says provide CAS repo, and then like there's this whole implementation, injecting of this and that. So this is basically the work of the module. It's like the place where you define all your dependencies and where they're coming from. We don't do that inside the class. It's done somewhere else. But we won't be doing this on our own. This will be done by something else. So I'll just delete all this and say provides repo. No. I will do it this way, but I don't want to create. So first off, I'll mark this as a module. Then I'll come here and say binds. So this kind of connects the interface with the implementation. Like we had this interface and the implementation. The interface implements. So this is what binds is mostly used for. Also, in the case that you have one interface, maybe you have cars, repository, and then you have car repository import, car repository. Like we have many kinds of car repositories. Binds is also what you'd use, and you can. There's how you can mark all this as different implementations. So let's say binds. So this has the car repository, and I think it's supposed to return the type of the interface. Yes. What am I missing? Oh yeah. So okay, the thing with binds is another thing I forgot to mention. If you're using binds, doesn't have, it's going to be abstract, meaning no abstract means it has no implementation. Like the implementation is going to be done by Hilt. So here, what we just need to tell Hilt is, hey, we have this car repository implementation. It's of this type. You take care of the rest. So this is what it means when it's abstract. So we can have multiple interfaces, and they will be implemented by the DI framework. And a good thing with using this Hilt or whatever is you can see there's these icons that show up. I think when you use Dagger or Hilt, that you can see the graph, or it will take you to where it's being used or being implemented, or where it's being injected, and the graph. There are also other plugins you can use with Android Studio to show you how your dependency graph looks like. What depends on what is injecting what etc. So yeah, I'll do the same for local storage, and I'll do the same for local storage, and what else do we, and room, I guess. Okay, room doesn't have an implementation, but we'll see how to. This was for cars local storage. So this is cars local storage import. Cars local storage import. And the one that's inside the brackets is the one that has the implementation. Yep. And yeah, this is the module. So we have this module, right? But the thing is, okay, we've created where, like we've already defined what maps to what binds to what, and listed them, and say this is a module that has all this information. But we haven't said where it needs to be installed. Basically, what this means is, so there, like I said in the beginning, there's with the Hilt Android app, for example, it signifies the app scope, the app's lifecycle. Then there's the Android entry point, which signified the activity scope, activity lifecycle. So there are different scopes in the dependency graph, or different life cycles for different objects. Some things are needed for the whole app's life cycle. Some things are needed only for a specific time. Some things are needed from time to time. And what this installed in basically is where like when you're defining what to put in installing, you have to think of what scope do you want the module, the things in that module to be in. So I think what we can use is, I think there are a few scopes defined in the documentation. Yeah, so there's, for example, singleton for application, generated components. Then there's view model components, activity, fragment, view with fragment, etc. for now, I think the ones that maybe you might find yourself using, singleton and activity, or maybe view model. The others, especially with compose, I don't think you'll find yourself with fragments and views. Okay, so I think for this one, I will just put it in the singleton. Because, yep. Singleton component, cool. Then let's say, what else do we need to do? The view model. Well, so for the view model, we can do something a bit different here. And with the view model, what we can do, because as you saw, this also has its own special kind of annotation. I can come here, and I think there should be something like, well, let's call it cars view model. Call it Hilt view model. And I think I need a dependency for this. Yes, I think I need to get the dependencies for this. I don't know if there is one here. I think I'll just look for one quick. And for Hilt view model, there needs to be, that's Hilt navigation. Hilt, where's Hilt view model? Hilt, wait, where's Hilt view model? I need to look for the dependency I need to import. Yeah, when using, okay, so I mean, we can't avoid using, I mean, you don't really have to use this, because I do know there's also using view model. There's also a nice view model one that you can also use, but just to keep it in the spirit of Hilt, I'll just use Hilt. If we did, and I can come. I think now we should be able to use a Hilt model. Hilt, yes. Hilt model, and I can call it cars model. Yep. And with that, I can then do whatever it is I want to do with this. Yeah, so this way, if you've ever tried injecting a view model without the use of libraries, you can know how daunting it can become. So you can use this from the library we just added. I think that one comes with the compose navigation library, but also you can use this view model kind of, this view model kind of library. I think you can use with one of these view model utilities for compose. Yeah, this one is also one you could use if you're trying to inject view models. Version 2.61. Yes, but that said, this is a very basic Hilt example. In the previous company, we did use Hilt a lot. Code base was filled with Hilt, and I think this should okay. I think this should be also the one I just added. It should be able to do something like the view models, the view model. Yeah, something like view model. Yeah. Yeah. So yeah, I think this is more for this is more on the navigation side because it felt a bit strange importing the navigation library for this. But yeah, there's this one. If you'll be doing something navigation related, maybe you can have a look at this one or this one. It's just something simple like this. And that's all for this with dependency injection. I think that's a lot of information to take in. Dependency injection wise, library wise. I'll share this project, and the documentation has everything else that you will see, some things that I've mentioned or some things that I've not mentioned. Yeah, this was just to show you what you could do, get your hands dirty with Hilt. So there's really, in terms of Hilt and Compose, there's they both exist independently. You could use whatever DI you use, but Hilt is, I guess, a bit more easy, and also the documentation is right there in the developer's blog. Also, as far as building composables goes, you won't really make use of Hilt that much. I think Hilt will probably end for simple scenarios. Hilt will probably end at the view model layer. Then from there, going on downwards to the UI, you probably won't use Hilt that much unless you are looking into the custom scopes I talked about a bit earlier. And yeah, that's pretty much it. But yeah, if you have any question, Hilt related or something specific you're doing with Hilt, I'm always free to talk about it. So yeah, I think I'll stop here. Let everyone soak the Hilt knowledge. Okay, so I think we can end this unless there's something else that was going to be said.
Thank you so much. And guys, now it's time for the questions. So anyone who has a question concerning about Hilt with Compose and also view models, because last session we talked about view models, so maybe you might be confusing on how to integrate between both those two in a real world project. So just ask them, and we'll be happy to share. So let me go first. So I've seen how you can reduce a workload of instantiating your classes with dependency injection. So each and every time you don't have to create an instance of a class, right? So now, with your view models, we know that view models, they survive the life cycle configuration, and basically they do not decompose with a compose, so something like that. So how, let's say I have a counting application that in every click event, an increment happens on a text composable. Now will I use the normal view models, or okay, which will manage the state, the view model or the Dagger Hilt one?
You're talking of the view model. So what Hilt does is it doesn't handle the view model things at all. What Hilt does is more on the preparing the view model, or how the view model is going to be provided, because it's more on a system level. So what Hilt does is, so if you are not using Hilt, you'd have to create this factory and define your dependencies that will be provided to the view model. So the system needs to kind of, be aware of these items need to be handled like this. This will be part of the these are the items that will be part of the when the configuration changes happens. Like I need to keep an eye on these items, or like keep them as they were. So Hilt is not really doing much on as far as configuration changes. It still falls on the view model side of things. Hilt just coordinates things.
Yeah, so Matindo has asked, thank you. Matindo has asked, does dependency injection affect the size of the application?
Good question. To an extent, I'd say yes, because if you look at the generated, there's usually like a generated folder of files files that are actually doing this whole connecting and coordinating of what is being created. So it does increase the number of files, which does, but I won't say it's significant or would warrant like some action on it. The files are very tiny, like bytes, few bytes, which compared to the size of Android apps, which are usually in megabytes, yeah, I'd say it's very not as significant as as like compared to the whole apps. Like if you compare relative with like other app files, it's very insignificant.
And yeah, I have another question. You know that Hilt survives configurations, and each and when composable are being recomposes, there are some things like memory leaks that can happen. So now, how can you avoid things like memory leaks, especially in compose-based application?
Memory leaks in compose-based applications.
Especially when the hierarchy is too big, especially when the component hierarchy is big and there are a lot of dependencies that are being managed. So,
okay, I see. Like you have a lot of, I think. So first off is how to prevent. I think that's just how to prevent memory leaks in general, not just compose related. It's how you develop your apps first. I think if you have a process of catching memory leaks to begin with. That's also a nice start, using tools like Leak Canary or looking at the profilers, or I think there's a compose debugging thing that was introduced to Android Studio recently, and you can check the trace of your composables, or see what is taking time or what is eating up memory consumption. So I think the first thing you need to do is have such measures of measuring like what is eating up my memory. Once you have that, then it will be easier to pinpoint why. You can why something is happening, and how you can best approach the issue, or if it's a common problem that is not only happening in your app but is like a known issue on like Google Tracker or like Canary have raised it. So in terms of memory leaks, I haven't really faced memory leaks. Also, it's maybe sometimes it could also be something not really related to. You may think the issue is coming from one place, but maybe it's happening somewhere else, and it has this domino effect on your UI composables.
Okay, thank you. So there's another question again. Is Hilt available in KMM?
Is Hilt available in KMM? I don't think I know that. I haven't really worked with KMM professionally. But I guess that's let me do a quick check. I don't think so. I haven't really heard of people talking of Hilt and KMM. Mostly I've heard people talk of Coin. I'm not sure. Coin is what I've seen. I haven't really seen people talk of Hilt, but probably I think you can check. You can maybe check with JetBrains. I think they maybe have a guide of some of the top libraries most people use. That's how I know whether or not. I think JetBrains have like, let me see. I think they have like a KMM shout out or top libraries people use for KMM apps. Is there any other? So someone asking what you prefer between Dagger, Hilt, and Coin. I mean, I go with Hilt most times because I usually tell, or like my way of choosing tools is I choose based on experience. So if I have most experience on something, at the high chance I will choose that, and that's why I'd go with Hilt, because I've used it in production app. I've also used Coin, but not really in prod, mostly in personal apps. And I think it depends. Each approach has its own downsides or cons. Hilt is more compile time. It'll have more compile time, issues, or your issues will be caught way earlier on in the development phase. And Coin is more of a runtime thing. I think your issues, you'll maybe realize them a bit later on. And this is, I think, why most people are against, or sometimes some people are against it. But it's still a very easy to adopt compared to other libraries. It's very easy to adopt Coin, especially in Kotlin projects. I think I'm more biased on, tilted on Dagger and Hilt, because that's what I've used most of the times. Also, all the apps, most of them will find are using like Dagger or Hilt, because that was pretty much the standard for a long time. A lot of apps that was like the recommended DI, kind of just like Alex Java and what's this thing called? Routines and flows. So yeah, it's I'd say choose what makes sense at the moment and what most familiar with. Or if I'm working with someone else, what we are both at least on level ground. And yeah.
Any other question, guys?
Is it necessary? Yeah, I think you don't really need to use these frameworks. If an app is small, I'd say go with manual DI in the beginning. Just you don't need to get all these dependencies, set up annotations, scopes, I don't know, and have all this noise happening. If you're like building a quick app, small app, do manual DI, then once you start feeling like manual DI is becoming a bit too much to handle, then convert it to, you can start using these libraries. I do know like there's some very huge or popular apps that used manual DI and just switched to these libraries after a while, and they're already like with thousands or tens of thousands of users or hundreds of thousands. So it's just nice to know of the tools that can make your work easy, but you don't necessarily have to use them if it doesn't make sense. I think it's up to, you just have the gut feeling whether or not it makes sense to use something. Don't just jump on the train just because other people are jumping on the train. Every app is different.
So yeah, I have a question for those guys who who are now done with in the intermediate level and they will looking for jobs in Android application development. What are maybe the bare minimums of the required tools and skills you need to have maybe to be considered as a junior level Android developer in a certain company?
Well, I think skills, so in terms of skills, let's say at least as an Android or mobile dev in general, at least you can build a UI. I think considering that will be quite core to what you're doing. You can build a UI that's functional. I think it's one thing to build UI and building UIs that's functional. You can at least make an API call. You can like connect your app with an API, because every other business has an API somewhere. They need to make some calls or do something with data, or APIs. You know how to save, store data. That's also a very important skill. Which other is a core skill, I'd say? But I think everything else you just build on the job. You just learn as you go, architecture, testing, dependency injection. I think it's nice to, you can show like you do have like a fundamental understanding of what it entails. Don't really need to know all these frameworks. And I don't know if I'm forgetting anything. I think those should be important. Those should be like the top things that you can showcase. Everything else is secondary or later on in your stage. Animations, testing, architecture, working with some deep things, media, Bluetooth, etc. Those are more higher or advanced.
Thank you. And guys, let's keep the question coming because we need to save a lot of time. And maybe for a portfolio, for a portfolio project, okay, what are the what do you call it? The minimum, not technically minimum, but really shows that this guy has a good understanding of the Android development. He has good understanding of an architecture, or maybe or is suitable to develop a small application that works and suits the needs of a user. So, like the user, yeah.
Yeah, I think people usually underestimate what you can do with a to-do app, but a to-do app can cover almost every point in Android. Actually, if you look at an app like Google Keep, it's a to-do app, but it's so you can have from it's linked to an account. It has saving both locally. It syncs with the server. You write, you can put text in it. You can put images. You can create like a custom looking lists. You can. So basically, I think a to-do app or a weather app. If you actually do think outside the box and see how, because in the beginning you're not really looking to be like the next Facebook or the next Netflix. What you're looking to do is to showcase that you understand concepts, like you understand how something is done. So if someone can just build a to-do app that has all this kind of functionalities, saving servers, it has notifications, reminders, alarms, services are running. So it might seem like just as like a to-do app, but there's a lot of things that you could actually do with what just seems like a to-do app.
So yeah, thanks. And anyone who has a question, we don't want to close for anyone.
Yeah, on the project bit again, it's not about doing, okay, you can do multiple projects, but you just have like one project and you're consistent with it and you build it over a very long time. Okay, you can also be doing your other small project, but you also just have one which you're always constantly improving, even months or a year. It will really help you build this skill on working with bigger, older code bases, like knowing how to maintain software. Because you're not just writing, so you also need to maintain it. So I think this will also open your maintenance, shape your maintenance skills.
And what before you forgot this question, I've been really wondering how Netflix manages to stream a video from a remote server. So we all understand that you can how you can use WebSockets, right, to maybe send a continuous flow of data. And is there a client library apart from Retrofit, which is known that is commonly used in REST APIs for like streaming?
I have used Exoplayer. Check out Exoplayer. Okay. That's the one I can say I've used for media related things. don't know, does it still exist? It's been a while. But yeah, I think. But for streaming, I don't. If it's let me just share it in. For playing media, I think for because I think Netflix is whatever it is they're using. So the thing is also the big apps or big, you probably don't really need what they're using because they're on a whole different scale. And they're serving probably a very unique purpose. And I think if you you can check out the Netflix engineer. They have a Netflix engineering blog, and they talk about some of the things that they do. Yeah, if you're looking for something that helps with media streaming, just send the link on the chat. That's what I've used before. You can see how you can use it for playing media in your apps.
Okay. Thank you. So any question, guys, before we close, because we are 22 minutes past the deadline. So yeah, I think that might be it for today. We are really humbled to have you, and really, especially me, I haven't really interacted with dependency injection. I've really wanted to, but I haven't had that stepping stone to start with. But I guess from now, I'm going to introduce them in my projects. Thanks so much, and I'm also hoping it's almost the same for everyone here. Let's keep doing a lot of coding. Don't just focus, take one or two projects and start doing them. You may never know how much you're going to learn from those projects. So take your project seriously. And yeah, thanks so much, David, for creating time for us. I know it's always good to have you and listen. Yeah. So we are also looking forward to having our next session. So guys, keep up with the community. More of these are coming, and also looking forward to having him. Yeah, in our next session. So you guys can tell us in the comment section what you like the next topic to be. Maybe in the coming future, what you like to learn. So we had proposed dependency injection last week after handling hoisting, state hoisting. So now can have something, maybe things to do with remote APIs, libraries like Retrofit and Ktor client. I've used Ktor client, and it's really amazing. You guys should try it out. And maybe David, he has something to say about it. Yeah.
Yeah, I've only used Ktor server actually. I haven't used the client, but yeah, I think I need to try it out sometime.
Yeah, so guys, the Kotlin ecosystem is really growing, and once you have that feeling of feeling safe with types, you'll never get out. So, but it's really amazing. So you should also try some of the backend framework that Kotlin offers. I recommend Ktor. I've also done a project with Ktor, and actually I'm looking forward to making it public for contribution as soon as I'm done with some of the things I'm doing. So guys, there's a lot you can do with Kotlin. 3 days ago, someone really asked me with Kotlin, what am I going to do with Kotlin? You can do a lot. Apart from only mobile app development, you can do some server-side development, even some, it's close to Java in what Java does. So it's good to you to have some knowledge in Kotlin. I think that's it for today. So thanks so much, David. And we are hoping to see you in the coming future soon enough. It's always a pleasure.
Likewise. and goodbye.
Okay. Yeah. Ciao, guys, and see you next Thursday.